the hyperbola. Now, one of the basic concepts in hyperbola is to determine its part. So this is a hyperbola with a transverse axis horizontal. Then in a hyperbola, we need to find first or locate the center of the hyperbola, which is, for this case, we have here the center of hyperbola, and then we also determine the vertex of the hyperbola. We have this one, and then the focus of the hyperbola, we have this one. So make sure that the focus, the vertex, and then the center are aligned. That is our hyperbola. And then we also have another part of a hyperbola is what we call as the conjugate axis. We have here it's not conjugate but the asymptote. So asymptote, we have here our asymptote. Okay, and then the conjugate axis, we have this one as our conjugate axis. This one is our conjugate axis. Okay, so that is our conjugate axis. And then we also have our the transverse axis. We have this one as our transverse axis. Take note that the transverse axis is always parallel or aligned with a line connecting the two vertices of the hyperbola. Then this one is covertex. We call this one as our covertex. Okay, take note, when you draw your asymptote, it will pass through the center, and then this rectangle, the four sides of a rectangle, we have this one. Okay, so this is our asymptote. Now, the equation of a hyperbola, if the transverse axis is along the horizontal line or along the x-axis or aligned with the x-axis or parallel to the x-axis, this is our transverse axis, then our formula x minus h squared over a squared minus y minus k squared over b squared equals 1. If the transverse axis is vertical, we have this one as our transverse axis, which is vertical, then we have our formula y minus k squared over a squared minus x minus h squared over b squared. Usually, in my case, I use b squared here, y over y minus k b squared. For this case, b is greater than a. Okay, so but because we have here our standard, then we will follow this formula. And then the formula for c, which is the distance from the center to focus, that is c squared equals a squared plus b squared. So take note, a, if you have noticed here, a squared, and then b squared, b squared. So x comes first minus y. That means the transverse is along x-axis or aligned with the x-axis. If, for example, we have here y comes first minus x, then our transverse axis is along y-axis. So a here, so in my case, I usually make use of b, y minus k over b squared. Pero for this case, we will just simply follow this one. Okay, so that we have a common. Now, in a, take note our a, that is from, we have here our a, the distance from the center to the vertex, that is our a. And then b is the distance from the center to the covertex, b. So that c is the distance from, let me change my color pen, the color of my pen. We have here from the center to its focus, that is c. Okay, so that when we solve the value of c, that is c squared equals a squared plus b squared. Okay, so that is how we compute the value of c. C squared equals a squared plus b squared. Take note, C is the distance from the center to the focus. And then A is the distance from the center to the vertex. Okay, so C squared equals A squared plus B squared. So take note again of our formula. If x minus h comes first before y, we have here, for this case, you have here x minus h, y, this one. And then we have here minus and then y. Okay, so it means our transverse axis is along x-axis. Okay, along x-axis. If, for example, y comes first minus x, so for this part, y minus x. Okay, we have here minus. That means our transverse axis is along y-axis. Okay, so y-axis or parallel to the y-axis. Now we will have our example. So we have here our example. Find the length of the transverse axis and the conjugate axis, foci, center, vertices, and equation of asymptotes of x squared over 16 minus y squared over 9 is equivalent to 1. Okay, so first we have to determine or rewrite our equation, that is x squared over 16 minus y squared over 9, that is equivalent to 1. Okay, x squared over 16 minus y squared over 9 is equal to 1. If you notice this one, there is no x minus h, there is no value of h, and then we have here y minus k squared over a squared b squared. There is no value of h and then k, therefore the center is at the origin for this equation. Okay, so that is at the origin, the center is at the origin, is at 0, 0. Okay, now rewriting this one again, we have here x squared over 4 squared minus y squared over 3 squared is equal to 1. Okay, so we have our a equal to 4 and then b equals to 3. So we will draw our hyperbola. We have here our hyperbola, the x and y coordinate, and then a is 4. We will count from the center, from the origin. We have here 1, 2, 3, and then 4. On the other side, we have here 1, 2, 3, 4. Okay, so this is the location of our vertex. And then our co-vertex, that is 3, 1, 2, 3, and then 1, 2, 3. So the location of our co-vertex. So this is 0, 3, and then 0, negative 3, co-vertex. And then this one is our vertex, which is at 4, 0, and then the other one, that is negative 4, 0. Okay, so we will now draw a line. Okay, so I will draw here a very thin line. Okay, we have this one. So we will draw the rectangle. Okay, we have here our rectangle. Okay, so that we will first locate the focus. So focus can be located as c square, or can be solved using the equation c squared equals a squared plus b squared, so that c is equivalent to the square root of a squared plus b squared, which is then equivalent to the square root of our a squared, that is 16, plus 9, that is 25. Square root of 25, that is equivalent to 5. So from the center to the right is 1, 2, 3, 4, 5. So we will count 1, 2, 3, 4, 5. And then on the other side to the left, 1, 2, 3, 4, 5. So this is now our vertex, I mean the foci. We will have this one as our foci. So I will write here f1, which is x is equal to 5, y is equal to 0. On the other side, we have here f2 as negative 5 and then 0. Okay. And then we will now draw, we will write first our asymptote. So how about the equation of the asymptote? We have, if for example the vertex is horizontal, then our equation of an asymptote of the asymptote, I will change the color for our asymptote. Okay, so we have this one, the equation of the asymptote. We have here y is equivalent to k plus minus b over a x minus h. This is our for horizontal. If we have a horizontal transverse axis, we have our asymptote equation, so that when we substitute the value, of course k is equal to 0, and then we have here plus minus our b, that is equivalent to 3, over a is equivalent to 4, and then we have here x. So we have two equations of asymptotes. We have y equals positive 3/4 x, and then y equals negative 3/4 x. So when we draw our asymptote, we have to connect this point, and then the center, and then the other point. So we will connect a line here for our asymptote. Okay, so this is our asymptote, and then on the other side, the other corner, we have this one as our asymptote. Okay, that is now our equation of asymptote. Y equals 3/4 x and y equals negative 3/4 x. And then we will now draw our hyperbola. So to draw our hyperbola, we have this one. Okay, so this is now our hyperbola. Okay, that's it. And then we also have here our hyperbola. Okay, so that is our hyperbola. Okay, so we have the length of the transverse axis. Transverse axis, its length is, of course, we have this one. The length of the transverse axis is from the vertex to another vertex, or 2 times a. That is the length of the transverse axis, which is equivalent to 2 times a. So we have here, let me change my pen color. Length of transverse axis equals 2 times a. Length of transverse axis, which is equivalent to 2 times a, which is equivalent to 2 times 4 equals 8. How about the length of the conjugate axis? Of course, 2 times. So we have here the length of conjugate axis, which is equivalent to 2 times b, which is equivalent to 6. 2 times 3, that is 6. So if we recall the length of the transverse axis, we have 8. The conjugate axis, we have here 6. Our foci is F1 50, located at 50, and then negative 50. And then the center, of course, at the origin, that is 0, 0. We have this one. And then the vertices, or the vertex, is located at negative 4, 0. We have here. And then positive 4, 0, the vertices. And then the equation of the asymptote, we have positive and negative 3/4. Okay, so these are our solution to this particular example. Now we will proceed with another example. Example 2, we have the given equation of a hyperbola. That is x plus 2 raised to 2 over 9 minus y minus 1 over 16. Of course, y minus 1 raised to 2, that is equivalent to 1. Find the center, the foci, the length of transverse and conjugate axis, and the equation of the asymptote. Now, if you have noticed here, the formula is based on the equation x minus h squared over a squared minus y minus k squared over b squared, which is equivalent to 1. If you have noticed, x comes first minus y. That means the transverse axis is along x-axis. Okay, that is the transverse axis, along x-axis. Now, for this case, our HK, the center, so our center is at HK. So that is equivalent to, this is x minus 2, y minus k. So our x here is minus 2, and then y, this is y minus k, so positive 1. Our k is positive 1. So we already locate our center of hyperbola. So that is x plus 2 raised to 2 over 9 minus y minus 1 squared over 16 is equivalent to 1. Now, after we locate the center, of course, we have to determine our a and b. For this case, our a is, this is 9, so 3. Our a is 3. And then our b is 4. Okay, so 4. So we have to draw our hyperbola. So if we draw our hyperbola, this is our y-axis, and then this is our x-axis. Okay, I will draw a line. Okay, so that is our x. I will draw our y. Okay, that is our y-axis. This is our x, this is our y-axis. Now, the center is located at negative 2, 1. So let me change my pen color. X is at negative 2, 1. X is as negative x. Negative 2, 1, and then 2, and then this is 1. So our y is 1. So the center is located here at negative 2, 1. Okay, so negative 2, 1. That is now the center of our hyperbola. Now, this is transverse axis, so a is 3. So we will count 3. We have here 1, 2, and then 3. So this is our vertex, and then on the other side, we have here 1, 2, 3. Okay, so when we locate our vertex, we usually count from the origin. It's not the origin, but it's from the center of our hyperbola. Okay, so if a equals 3 and b equals 4, then if we want to compute the foci, okay, foci, we have to solve c, which is equivalent to a squared plus b squared, which is then equivalent to the square root of our a squared, which is equivalent to 9 plus 16, that is square root of 25, which is then equivalent to 5. So from the center, you will count 5. We have here 1, 1, 2, 3, 4, 5. So that will be our focus. We have here 1, 2. Okay, we have here our focus. Take note, this is our focus, F1. And then this one is our vertex, this one is our center. And then on the other side, we will count again 5. 1, 2, 3, 4, 5. So expect you have here 1, 2. So we will erase this one. So this is our foci, F2. Vertex and then foci. Okay, so vertex and then foci, 3, and then our B is 4, going upward and going downward. So take note, our center, this is our center. Okay, going upward, going downward, we will count 4. Because B is 4, we have here 1, 2, 3, 4. Going upward, 1, 2, 3, 4. Okay. So that we will draw our rectangle. Okay, this is our vertex. Okay, so we have here our co-vertex. And then we also have here, extend our line. Okay, that's it. And then we will draw our asymptote. We will draw our asymptote. So let me change my color. Connecting the center. We have here our asymptote. Sorry for that one. Okay. Again, we have here. So it must pass to the center. Okay, and then the other one, we have here our asymptote. Okay, that is our asymptote. And then we will draw our graph. Later on, we will indicate some of the points from our vertex. So our graph is this one, our hyperbola. Let me change my color of hyperbola. We have here this one. Okay, this is our hyperbola. Okay, so we have here our hyperbola. That is our hyperbola. Now we will now identify the different points of our hyperbola. This is our vertex. Again, this is our vertex. The vertex is located at 1, x equals 1, y is equal to 1. Okay, x equals 1, y is equal to 1. The vertex of the hyperbola. X is equal to 1, y is equal to 1. How about the other one? This one is x equals 1, 2, 3, 4, 5. Negative 5. And then negative 5 and then 1. The value of y is 1. Okay? Is 1. from the origin, we have here 1, 2, 3, 4, 5. Okay. Next, so that is from negative 1, I mean negative 5, 1, and then 1, 1. Now, how about the foci? So, from the origin, our foci is located at 1, 2, and then 3. So, this F2 is located at 3, 1. The value of y is 1. On the other side, we will count here 1. Okay, okay. We will count from the origin. We have here 1, 2, 3, 4, 5, 6, 7. So that is negative 7. Our foci, F1, negative 7, and then 1. The value of y equals 1. That is our F1. I will rewrite F1. Okay. So we have the foci, length of conjugate and transverse axis. So the length of conjugate axis. So the length of conjugate axis, that is equivalent to 2 times our conjugate is b. 2 times 4, that is 8. How about the length of our transverse axis? That is 2 times 3, which is equivalent to 6. So we have here the length of conjugate, the equation of asymptote. Okay, for the equation of the asymptote, I will change my color of my pen. Okay, the length of the, or equation of the asymptote, we have y is equivalent to k plus minus, we have our, if this is horizontal, that is b over a, x minus h. So we have our k is 1 plus minus our b is 4, and then our a is 3. X minus h, our h here is negative 2. So this is minus negative 2. So that this is now equivalent to 1 plus minus 4 over 3 x plus 2. Okay, rewriting this one, our final equation, our 1, we will transfer this one to the other side. That becomes y minus 1 is equivalent to 4 positive negative 4 over 3. Okay, I will know. Okay, it's okay. 4 over 3 x plus 2. You may transfer 1 on the other side, or it will remain on this side. So we can have it here. If I will retain it on this side, that means 1 plus 4 over 3 times x plus 2. And then the other equation is 1 minus 4 over 3 x plus 2. So this is now the equation of our asymptote. So as a recap, the equation of, the center, we have here negative 2. That is our center. And then the foci, we have here F1 and then F2. And then the length of the transverse and conjugate, we have 8 and then 6. And then the equation of the asymptote, we have this one. Okay. Another example, we have given the vertices at 5, 0 and negative 5, 0, and the foci at 6, 0 and negative 6, 0. Find the equation of asymptote and the hyperbola. So we need to find the equation of the asymptote and then the equation of the hyperbola. So of course we need to draw our hyperbola. First, the vertices are located at 5, 0 and negative 5, 0. So we need to plot our hyperbola. We have, okay, so let me draw it again. Okay, and then so this is out of my control when I draw a line. Okay, so x at 5, x at 5, y is 0, and x is negative 5, y is 0. So we have here 1, 2, 3, 4, 5. On the other side, we have here 1, 2, 3, 4, 5. So vertex 1, so let's say this is v1, and then v2, the other vertex 5, 0, and then negative 5, 0. These are our vertex. Okay, so I will mark our vertex at v1 and then v2. So I will change this one to red. Okay, this is our vertex v1 and then v2, and then the foci is at 6, 0, negative 6, 0. So we will extend by 1. Okay, so we have here 6, 0. So I will mark here as our foci. Okay, f1 and then f2. This is our f1 and then this is our f2. Now, given, if you have noticed, if you observe foci and then the vertex, of course our center is at the origin for this case. This is our center. Now if that is our center, okay, so let me change my pen. If this is our center, then the distance from the center to vertex is equivalent to 5, which is then equals to 5. And then the distance from the foci to the center is equivalent to 6. That is our distance. Therefore, we have now the value of our A, which is equivalent to 5, and then C, which is equivalent to 6. So we do not have a value of our B. So to compute, to find B, we have here C squared equals A squared plus B squared. This is our formula. So that when we compute B squared, that is equivalent to C squared minus A squared. Okay? So transfer A to the other side, that becomes negative. So C squared minus A squared equals B squared. So that when we compute our B, that is the square root of C squared. Our C is 6 times 6, or 6 times 6, that is 36, minus A, that is 5 times 5, that is 25. So 36 minus 25, that is 9. So square root of 9, that is equivalent to 3. Okay, so we have 3 as our B. So we need to plot here 1, 2, 3, 1, 2, 3. So that when we locate our covertex, then we will now draw our rectangle. This is our rectangle. Oh, I will change the color of our rectangle. Fine chisel na lang. So we have this one, and then from the vertex we go downward and then upward, and then we will have this one. Draw the rectangle. Okay, and then we will now draw our hyperbola as well as the asymptote. So this is our hyperbola, I mean the asymptote. We have this one. Okay, we have this one. And then we have also here our asymptote. Okay, and then our hyperbola. Okay, so we have this one as our hyperbola. Okay, that is our hyperbola. Okay, we will now try to trace up the different points. Okay, so since this is the transverse axis is horizontal, then we have our x squared over a squared minus y squared over b squared, that is equivalent to 1, because our transverse axis is horizontal. Okay, if you have noticed here, this is our transverse axis which is horizontal, so along x or parallel to x. Now when we compute this one, we will simply put the value x squared over a squared. Our a here is 5, so 5 square minus y squared over b. Our b is equivalent to 3 square, that is equivalent to 1. So we have x squared over 25 minus y squared over 9 is equivalent to 1. 9 times 25, we will make use of our calculator. 9 times 25. Okay, we have here our, okay, there's a problem with my, okay, calculator. 9 times 25, so that is equivalent to 225. Okay, so we will multiply both sides by 225. Okay, so if we multiply both sides by 225, then it's equivalent, this one, 225 divided by 25, that is 9. So 9x squared minus this one is 25y squared, that is 225 divided by 9 equals 25, which is then equivalent to 2 to 5 times 1, that is 2 to 5. Or if we equate this one into 0, we have 9x squared minus 25 y squared minus 2 to 5, that is equivalent to 0. So that is now the equation of our hyperbola. Okay, equation of the hyperbola. How about the equation of the asymptote? So again, the equation of the asymptote equals, I will change the color of our asymptote equation in writing the equation of the asymptote. So y, this is again horizontal, so we have here y equals k plus minus, so this is horizontal, that is b over a x minus h. So we have y equals, k is 0 because that is at the origin, and then we have here plus minus b. Our b is equivalent to 3 over 5. Our a is 5. Okay, so 3 over 5, and then x. So this is now the equation of our asymptote. Again, to recheck our equation of a hyperbola, we have this one. or actually we can have this one, okay, but I prepare to equate this one into 0, and then the equation of the asymptote we have here. Last example, we have number 4, 16x squared minus 9y squared minus 32x minus 54y minus 641 is equivalent to 0. Now, this is the equation of a hyperbola. So, we need to find the center, again the center, the vertices, and then the foci, and then the asymptote equation. Okay. Now, of course, we have to group x and then y. All variables with x we have to group, and then all variables with y we have to group. So for this case, we have our solution. So we have 16 x squared minus 32x. Okay, and then we will add a number here later on. So I will make it as blank because we need to have a perfect square. And then we have minus 9y squared minus 54y, and then we need to add another value here later on, which is then equivalent to this negative 641 will be transferred to the other side. That becomes positive 641. And if we add two values on this side, then we will also add another two values on the other side. Okay, so we have this one. Now, how will you know that the hyperbola, I mean the transverse axis of the hyperbola is horizontal or vertical? How will you know that the transverse axis of the hyperbola is horizontal or vertical? If you look at this one, your x is positive. Your y is negative 9y squared. That means since x is positive, then the our transverse axis is along x-axis. So we expect to have this kind of hyperbola. Okay, so let me erase that one. Now, going back to this our problem, if we have here 16 x squared, then we need to factor 16 for x. So we have 16 times x squared, then this one 32 divided by 16, that is minus 2x, and then we need to add a number here so that this will become a perfect square. So to make this as a perfect square, we divide this 2x by 2. So negative 2 divided by 2, that is 1, and then square it. So we have negative 2 divided by 2 equals negative 1, and then squaring this one, that is 1. So we have here 1. Okay, take note, we have added 1 from this part, so I will highlight this one. Okay, so take note of that. Now minus, we will factor 9 minus 9 times this one is y squared, and then 54 divided by 9, 9 times 6 54. Okay, 9 times 6 54, so 6y plus 6y. Why should I make use of plus? Because this is negative 9. Negative 9 times 6, that is negative 54. Okay, now for this part, again we will add a number here. So to make it a perfect square, then we have this one 6 divided by 2, again divided by 2, and then that is equivalent to 6 divided by 2, that is 3, and then square this 3, square this one, that is equivalent to 9. Okay, so we will add 9 here. Okay, so close this one. Again, I will highlight 9. Okay. Now, equals 641 plus, we have the unknown value here. So, if you have noticed on this part, we add 1. We will multiply 1 times 16. So, 16 times 1, that is 16. So, we will add here 16. And then on this side, uh, we have here 9. 9 times negative 9, that is negative 81. So, we have here negative 81. Okay? So, we will add these two value. Now, I will erase this one. The explanation of this number, I will erase it. Okay. So that when we compute here, calculator, oh, we have our calculator as 641 plus 16 minus 81. That is equivalent to 576. Okay? 576. Okay. Okay, so actually we already calculate this one. It's no longer 641 but it is 576. 5 okay, sorry. 576. Okay? So again, 576 is equivalent to 641 plus 16 minus 81. So that is 576. So we will, if this is 576, then the next step is, of course, we make this one as our perfect square. We have here 16 times, this is x minus 1 square, okay, minus 9, this one is y plus 3 square, okay, which is equivalent to 576. And then why do we need how did we arrive at x minus 1? Remember this one, we have x squared minus 2x plus 1. A while ago, we divide negative 2 by 2, that is negative 1. Okay? On the other one, we have here y squared plus 6y plus 9, or a certain value. We divide 6 by 2, which is equivalent to 3. That is y plus 3, and then this one, x minus 1. So, that is the main reason why we have that equation. Now, if we have here 576, our general equation is this must be equal to 1. So we need to multiply both sides by 576. Okay, we will multiply by 1 over 576. So that when we multiply this one, this is 16. So x minus 1 is squared divided by, so 576 divided by 16, or 16 divided by 576. So that is equivalent to, using your calculator, so we will have a calculator again, 576 divided by 16 equals 36. Okay, so this is 36. Okay, let me transfer this one, calculator. Okay, so 36. This is 36 minus y plus 3 is square. So 576 divided by 9. So we will multiply 5, okay, 576 divided by 9. That is equivalent to 64. So we have here 64, which is equivalent to 576, 576, that is 1. So this one is x minus 1 squared over 36, that is 6 times 6, so 6 squared, minus, this is 6 squared, minus y plus 3 square divided by 64, 64, 8 times 8, 64, so 8 squared is equivalent to 1. So that our A is equivalent to 6 and then B is equivalent to 8. Now, to find the center, of course, we have here negative 1 and 3. X minus 1, y minus 3. So, 1 and negative 3. So, x is as 1, y equals negative 3. So, we have here, okay, and then y equals 1, y equals x equals 1, x equals 1, y equals negative 3, 1, 2, 3, negative 3. So this is now the center of our hyperbola. And then A is 6, so we will count 6. I will make here 6 as our transverse axis. 6, we have 1, 2, 3, 4, 5, 6. And then on the other side, we have here 6. From the center, we have here 1, 2, 3, 4, 5, 6. Okay? This is now our vertex. So I will mark it here, our line. Okay? And then on the other side, we have here 1, 2, 3, 4. Align lang, align. 5, 6. Okay. Then 8 going upward, going downward, 8. So 1, 2, 3, 4, 5, 6, 7, 8. Going upward is 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have here 1, 2, 3, 4, 5. Okay. So when we level now our vertices, we started with here from the origin, we will count 1, 2, 3, 4, 5, 6, 7. So our x here is at 7. And then our y is 1, 2, 3. So negative 3. Negative 3. Okay? This is our vertex. On the other side, we started from 0. So we have here 1, 2, 3, 4, 5. So that is negative 5. Negative 5. And then the value of y is 1, 2, 3, negative 3. Okay? So that is now our vertex 2. That is the second vertex. Next, we have done with the vertices, the center, and then the foci. Of course, when we solve foci, we need to find the value of c. So c is equal to the square root of 6 squared is our a squared plus 8 squared b squared. That is equivalent to 6 times 6, 36. So we have our calculator, 36 plus 8 times 8, 64 equals 100. Square root of 100, that is 100. I mean 10. Square root, that is 10. Okay? So 10. C equals 10. So if we have the value of c equals 10, then from the center, okay, from the center, this is 6, 1, 2, 3, 4, 5, 6. So since we have 10, so 6 we add 4, 1, 1, 2, 3, 4. Okay, so this is now our focus. Okay, and then the other one, from the center, we count 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have here also. Okay, same with this one. Okay, so our center, I mean the focus, we have this one, F1 and then F2. So our F1, I will color this one. Let's say this is our F1, which is located at, again, when we count from the origin, we have here 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9, negative 9, and then y is negative 3. That is our focus 1, F1. F2, from the origin, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so we have here our F2 is at 11 and then negative 3. So we have our foci and then the asymptote. This time, our asymptote, again, the asymptote equation. Okay, I will change my pen color. Again, our equation of the asymptote, we have y is equivalent to k plus minus, okay, so plus minus b over a x minus h. So y is equivalent to our k, hk, where is our center. We did not write here our center, so I will write here our center is at x at 1 and then y is negative 3. Okay, so hk, so negative 3, our k is negative 3, and then plus minus our b is equivalent to 8 over 6 x minus h, our h is hk minus 1. So I will transfer negative 3 on the other side. That becomes y plus 3 and then 8 over 6, so plus minus, reduce to lowest term, that is 4 over 3. This is 4 over 3 and then x minus 1. This is now the equation of our asymptote. We have this one.